Hello, my name is Saki Kamon. I'm a data scientist interested in natural language processing and predictive modeling. So 5 years ago, I watched the trailer for the film adaptation of Ender's Game, and I immediately bought the book, read it before watching the movie in theaters. At that time, I thought I first saw the next blockbuster series, and I had looked forward to seeing the Ender's Game quartet on the big screen. As of today, there's no talks of any adaptations for the sequel, other than some considerations for making a television series. This is just one of many examples of why I wanted to do this project, which is finding the probabilities of a book being made into a film. Going into this project, there was one challenge, the fact that there's an imbalance class. Considering that there's 130 million books in circulation and about 30,000 movie titles that have been tagged based on novel in the Internet Movie Database, I had to be careful when making my models. Setting aside my bias, my intuition was that content mattered, and I documented the steps I took to test my hypothesis. My data was collected from the Goodreads website, and based on the information I gathered from that, my feature and text analysis relied on using the scikit-learn and the natural language toolkit packages. Then, after looking at some results, then I tied it all together in an interactive web application to showcase my findings. My data was collected through a Python interface for the Goodreads API. I accessed about 25,000 books and their corresponding authors and stored it all in a Mongo database. I relied on scraping Wikipedia and the Internet Movie Database websites to determine which books have cinematic adaptations. Among the information I was able to collect, I was able to access features such as the year of publication, the number of pages, and even something about the authors such as gender and the number of works they have done. Regarding for the summaries, the approach I took for analyzing that was splitting the summaries into words, filtering out the most common words, and then converting them into a matrix of features to be analyzed with the rest of my categorical features. Among the various classifiers, the best performing was using a logistic regression, and I assessed its performance by optimizing the recall, as I did not want to have many books that do not have a film adaptation to be labeled as having a film adaptation. And this graph on the left highlights how well my model did. On the left, we see the distribution of the books that do not have a film adaptation, and on the right, we see the distribution of the books that do have a film adaptation. And as you can see, the majority of books that do not have a film adaptation are skewed to the left side of the graph, and then for the movies that do have a film adaptation are skewed to the right. But the most interesting case about this was looking at the tail for the distribution of the books that do not have a movie, because I anticipate that these books will have a film adaptation sometime down in the future. And here are some example books to your right, such as Catcher in the Rye, The Four Birds, and Stargirl. And to tie everything together, here's a demo of a website that would showcase my findings. If you go to this app and type in one of the following fields, such as book, author, and ISBN, the results will display the author, my predictions, the summary, and reviews about the book. And if you wanted to learn more about the project and look into the documentation, there is a link that redirects you to my GitHub page. Considering the future steps, I would like to scale up and work on a larger data set to fine-tune my model. Another consideration is that I would like to leave the project alone for a while and then come back to it to see if the predictions I made for the books that may have a film adaptation were correctly identified. If you have any questions, please reach out to me through LinkedIn or email. Thank you.